So in the last class, I had explained about the different time estimates, optimistic time, pessimistic time, and most likely expected time, and also expected time. So expected time TE was given by TO plus 1 times TL plus EP divided by 6. It is an average value. So more weightage is given to this likelihood time. So this is optimistic, this is likelihood time, this is pessimistic time. So this is called as expected time. For an event to be completed. Now there is one more term called earliest expected time. Earliest expected time. Because normally in any project, one important thing is we have to consider a path which can give the expected time as minimum. That means the earliest, so that all the activities are completed within that time. So this is another thing. It is denoted by capital TE. Actually, this is it can be defined like this. It is the time. It is the time when an event can be expected to occur. When an event can be expected to occur. So usually it will be in hours or days, depending on the type of the project. So this TE can be obtained by adding all the expected times of all the activities along a path. That means it is sigma TE for all the paths which cover the activity. So here this is obtained by this leading to that event. Suppose if more than one activity is there, then T is taken as the maximum of sigma T of all the paths. Maximum of sigma T of all the paths. Suppose if there is a single path, then it is sigma T. If it is there are number of paths are there, then you have to take the maximum of sigma T. So this actually you can explain by taking a simple example. Let me take a simple example of there are 3 events. 1, 2, 3 events are there. 1, 2 is an activity. 2, 3 is another activity. So here I will write the 1, 2 activity, the timings being 4, 6, 8 units. That is maybe days or hours. 2, 3 is 5, 7, 12. And 3, 4, one more I will take. For 3, 4 it is 4, 10, 13. So in the earlier video I have told that these 3 values represent this T0. First value represents the optimistic time, second value represents the likelihood time, third value represents the pessimistic time. So it is in increasing order. So these are the T0, TL and TE values for the 3 different activities. Now from this you can calculate TE. So TE for this, TE for the activity 1, 2 is given by, if you use this formula, T0 is 4 plus 4 times 6, because TL is 6, plus 8, TP is 8, divided by 6. So if you simplify this, you will be getting 4 plus 24, 28, 28 plus 8, 36, you will be getting 6. So TE value for the activity 1, 2 is 6. That is the expected time. For the activity 2, 3, TE value is given by T0, that is 5, plus 4 times TL, that is 7, plus 12 TP divided by 6. So if you simplify this, you get 5 plus 28 33. 33 plus 12, 45. 45 divided by 6 is 7.5. So we are getting 7.5 days or hours, whatever you are given. Next, for the activity 3-4, TE value will be, or similar lines will be the same formula. T naught is 4 plus 4 times 10 plus 13 divided by 6. So it is 40, 44, 57. 57 divided by 6 is 9.5. So these are the values of TE for the three different activities. That is small t. Now how to calculate capital TE? So let us see how we can calculate capital TE. So if I take this capital T value for the first, capital T values are written here above this circle. Let us take that there is I am starting the project now. That means your capital T value is 0 for event 1. It is starting 0 for event 1. Now for this second event should be completed after 6 hours. This value you have to take. That means you have to add 6 to this 0. So here the T value for the second event will be this 0 plus this 6. So it is 6 days or 6 hours, whatever it is. Next, for the third event, it should be TE should be TV of the previous plus this small t. That means it is 6 plus 7.5, 13.5 units, days or hours. Next, for event 4, TE will be equal to T of the previous one, that is 13.5, plus small t of this activity, which is 9.5. So totally it comes to 23. So therefore, the expected, that means what you can say, the earliest expected time TE for the completion of the project is 23 days or 23 hours. That's what we have to calculate. This is when I take up a single path. This is a single path. When you go for multiple paths, more than one path, then we have to take the maximum of sigma TE values of all the paths. Now let us take a problem. Actually, you see how it is written in any path. So it is written like this. Events are represented by circles. Small t values are represented here. They are going to give T0, TL, TP values. Here we are going to write small t value. Here also they are going to give T0, TL, TP value. This is T value for this. So this is T value for 2, 3, T value for 1, 2, activity 1, 2. Here T value for activity 3, 4, and T0, TL, TP for the activity 3, 4 is given there. And we are going to write this earliest expected time above this circle. So T for this we are going to write here, T for this we are going to write here, T for this we are going to write here, T for this we are going to write. So this last value of T, that gives the earliest expected time of the completion of the project. So this is how in a diagram it is written. Now let us take that means here if we take this example, it is written like this. Here it is T is equal to 6, here T is equal to 7.5, here T is equal to 9.5, here T is 0, here it is 6, here it is 13.5, here it is 20. So this is how we are going to write a path showing in this. We have shown all the timings. So optimistic time, likelihood time, pessimistic time, expected time, earliest expected time, capital T. So all the time estimates are written in a path like this. Now I will take up a problem in which there are multiple paths. So in the case of multiple path, the procedure is same. Only thing is we have to calculate sigma DE for all the paths, and then we have to take the maximum value of the sigma DE as the value of capital T. So now this is the network diagram given. Event 1, event 2, these are connected like this. This is event 3. Then from this 2 it goes to 4, event 4. Then from 2 it goes to 5. Then from this 3 it goes to 6. From 5 also it goes to 6. Then 4 it goes to 6. So like this. Now in this example, instead of giving the T0, Tn and Tp, directly he has given Te values. So you know how to find out Te value once they give these three values using this formula. But in some problem they may give directly the value of Te. So in this problem they have given directly the value of Te. For this Te is equal to 5 from 1, that is activity 1, 2. For 2, 3, T is equal to 10. For 2, 4, T is equal to 8. Maybe days or hours. You can say units. Then you have for 3, 5. 3, 5 is also there. For 3, 5, the value of Te is 7. For 3, 6, T value is 4. For 4, 6, Te value is 8. For 2, 5, Te value is 12. And for 5, 6, Te value is 5. So this is the diagram, network diagram. Now of course, unless it is specified, you can take this capital Te value for the first event as 0. Now the question is, what is the Te value for the last event? That means, what is the earliest expected time for the completion of the project? Because 6 is the head event, which is the last event in the network. Now, let us calculate the values of capital Te for all the events. So I will write events capital T. Of course, it is in units, so he has not given anything days or hours. So now the events are 1, 2, 3, 4. You can see here 1, 2, 3, 4. 1, 2, 3, 5. 1, 2, 3, 5. For these 4 events, let us write. For 1, actually the value of T is 0. Always the first event is the starting of the project, therefore T is 0. For 2, what happens? So what you have to do here is, if you observe this example, if you want T for any event, it is nothing but T of the previous event plus small t of the activity. Or in other words, I can write like this. So you can use this formula. If you want Te, suppose if I take this as I, this as j, this activity becomes ij. In terms of ij, you can write I is the first event, j is the second event. Or if you take these two, I becomes 2, j is equal to 3 like that. Activity is ij. So Te of j, if you want, it is nothing but Te of I plus small t of ij. And this is the formula which we are using. So this is important. Now this T of j, suppose if only one activity is connecting to this j, then it is only one value. Suppose if there are more than one activities, for example, you take this 5. This 5, there are 2 activities connecting to 5. So that means we have one path like this. 1, 2, 3, 5 is one path. 1, 2, 5 is another path. Similarly, for 6, we have different paths. There are totally 3 paths further. So we have to calculate this capital Te for all the paths, and we have to take the maximum of the value. Now let us see how we can do this. Here, for 2, what happens? 2 is connected to only one predecessor. This is predecessor event. So for 2, t of 1 we have to take, which is 0, plus small t of 1, 2 we have to take, which is 5. So this is 5. Then for 3, I have to take now t of 2. T of 2 I have to take, which is nothing but 5, plus t of 2, 3 I have to take, that is 10. 15. I am using this formula. So this J stands for any event, I stands for previous event or predecessor event, and Ij stands for the activity. So small t represents for the activity, capital T represents for the event. Now when we come to this 5, here you should be careful. When you come to this 5, you have 2 paths leading to this 5. So what are the paths? 1, 2, 3, 5 is one path. Okay. So now I write here. There are 2 paths here. First path is 1, 2, 3, 5, and second path is 1, 2, 5 directly. Okay, for 5. It is like this. Now here you have 2 values for 5. So the first one, if you want the first one, so what you have to take here is, I have to take t of, this is the predecessor now. So t of 3 I have to take, event number 3 I will write here, plus t, small t of 3, 5 I have to take. Okay, previous history for this path, previous predecessor event is 3. So I have to take capital T of 3 plus small t of this 3, 5 activity. So this is nothing but this is T3. Please note that this is T3, this is T2. Now that means this is 15 plus for this activity it is 7. So 22. So 22 is the answer there. Next, if you take 1 to 5, in that way if you calculate, for 5 predecessor is 2, that means I have to take T2 plus this small t of 2, 5 I have to take. So that means it is T2 is 5 plus T25 is 12. So 17. So like this. So we have 2 paths leading to 5. Therefore, you will get 2 values of TE. Now among these 2, the higher value is 22. Maximum we have to take. See, maximum we have to take. So this value we have to take for further computations. So this is the higher value. So like this, if you have one more path, for that path also you have to calculate TE, and among the 3 higher value we have to take. So this is for the 5th one. Now let us, last event is 6 now. Let us come to the last event. So last event 6, it will have, event number 6 will have 4 paths. So this is what we are interested now. Final value of T we can get. Event 6 can be achieved using 4 paths. First path is 1, 2, 5, 6. 1, 2, 5, 6 is one path. Second path, so you can call it as path A. Path B is 1, 2, 3, 5, 3, 1, 2, 3, 6. 1, 2, 3, 6. Next, path C. Path C is 1, 2, 4, 6. 1, 2, 4, 6. One more is there. So 1, 2, 5, 6 is 1. 1, 2, 3, 6 is 1. 1, 2, 3, 5, 6 is 1. 1, 2, 3, 5, 6. It is also there. And path D, fourth path is 1, 4, 6. See, these are the 4 paths leading from 1 to 6. 1, 2, 3, 6, first one. 1, 2, 5, 6 I have to, okay, 1, 2, 3, 6 only, okay. Let us come in the order. 1, 2, 3, 6 is first part, 1, 2, 5, 6 is second part, 1, 2, 3, 5, 6 is the third part, then 1, 2, 4, 6, 1, 2, 4, 6. Yes. These are the 4 parts leading from event 1 to event 6. Now let us calculate the T value for the last event 6 due to all the 4 parts. So you should be careful here now. We will get 4 values of TE. So TE6 from the first, TE6 is equal to, so here you can see the predecessor is 3 in this. If you take this part, predecessor for 6 is 3. So TE6 will be TE3 plus activity of this T for this activity, small t of 3, 6. Yeah, which is nothing but T of 3 is nothing but here I have given 15. It is 15 plus T of 3, 6 is given as 4. So 15 plus 4, 19. The first value of T for the first part is 19. Now for the second part 1, 2, 5, 6, the predecessor of 6, that is once again we can write TE6 is equal to, here the predecessor is 5. So TE5 I have to take plus small t of 5, 6. Small t of 5, 6. So t of 5, we should be careful here, this value. Highest value I have to take, not this. So we have to take 22. T of 5 is 22. This is your T of 5. Highest value. So 5 plus T of 5, 6 is 5. 5 plus 5, 10. Or T of 5 is 22. 22 plus 5, it is 27. That is second value of TE. Next, third value, that is part C. Part C is 1, 2, 3, 5, 6. Here also, TE6 is equal to, the previous event is 5. So I have to take TE5 plus this one. Which one I have to take? 5, 6 only I have to take, okay? So TE plus 5, 6 only I have to take, which is TE of 5, 6. Here also it is same, 22 plus 5. TE of 5, 6 is 22 plus 5, which is 27. Lastly, for part D, it is 1, 2, 4, 6. So for 6, predecessor is 4. Therefore, TE of 6 you can get here. So TE of 4 plus TE of 4, 6. Now I want the TE of 4 here. What is the value of TE of 4? I can write here only TE of 4. For the fourth event, the immediate predecessor is 2. Okay? TE of 4 is nothing but TE of 2 plus small t of 2, 4. This event. So that is T of 2 is 5 plus, and for this activity it is 8. So 5 plus 8, it is 13. So therefore this value will be T of 4 is T of 4. This value is your T of 4. Okay? This is T of 4. So T of 4 is 13 plus T of activity 4, 6 is 8. That is 21. Now like this we got 4 values for the earliest expected time. So among this we have to take the maximum value. So maximum value we have to take. Now here the maximum value you are getting 27. So both these two are equal to 27. These are the maximum values. So therefore what we can say here is this either path B, so maximum TE is equal to 27. So it is for both path B and path C. Therefore, the earliest expected time PE for the entire project is 27, maybe days or hours. Usually it will be days. Okay, so that is the answer. So this is how we can compute earliest expected time capital TE when we have number of parts for the completion of the project. If it is a single part, we can use this. Anyway, this is the general formula which gives the relationship between the earliest expected time TE and the expected time TE. So this is for the activity. These two are for the events. So if you want earliest expected time for an event, it is equal to earliest expected time of the previous event plus the expected time of the activity related. So this is how we can find out the earliest expected time in a given project given the network. Only thing is they should give the small t values or they will give T0, TL and TP. If they give T0, TL and TP, T is calculated using this formula first, then the capital T is found out using this method.